So today we will do two tests, right? One is wheel tracker test, other is a demo of loader compactor. So now we will see, before wheel tracker test, we will see what is rutting. In the class I have told that, so rutting is where it's a permanent deformation. So rutting can happen in two types. One is the mixed rutting and other is the spread rutting. You can see the difference between these two particular pavement cross sections. If you see here, the rutting is seen only in the bituminous layer. Here, the rutting is seen in all three layers: this bituminous layer, granular layer, and subgrade layer. These kind of rutting are mainly because of structural inadequacy. Means whenever the overloading is there, or where the pavement is not structurally adequate to take the load, or the pavement is at the end of design life. So that kind of failure is subgrade rutting. But what happens in the initial day itself, in the initial within 1 year or 6 months itself, there can be these kind of failures where only rutting can be seen in the mix, but the other layers are still intact. You see here, the deformation is only in the bituminous layer, and if you see here, at these positions where the wheel path is there, here there is a uplift of the mix. That means what? The mix is not able to take the load. Right? The mix is not stable, right? So in that case, it's a issue with the mix. So mix is not either designed properly or it is not aired properly. So there is a problem with the mix and it has to be rectified. Now these kind of issues, right, the laboratory can be identified using wheel tracker test. The wheel tracker test gives an idea how the mix will perform. So let's say we can create different gradations, different bitumen content, different air wash content, and study the wetting behavior of the bituminous mix only, not the pavement structure, only wetting behavior bituminous mix using wheel tracker test, right? So we can identify how the mix will behave in the field, right, by doing a simple test using wheel tracker test, right? So we will give a demo of the method in the below laboratory. Before we go for roller compactor. Now what is roller compactor? You might have seen that when we lay pavement, right, we use rollers to compact. Rollers can be a static roller or a vibrating roller. So the vibrating can be, the compaction can be either static wheel roller or a vibrating wheel roller. But see, if you see in the laboratory, we use methods like Marshall compaction, right? Other is super paved direct compaction. So we will discuss this both later on. So in the Marshall compaction, we use impact load, where using a proctor hammer. Same kind of hammer we use for different weight and height of fall. So we will impact the mix from prepared hot mix, right, using this Marshall hammer. So it's the impact loading, which is quite far from the actual loading or actual compaction thing, what happens in the field. But it is super wave gravity compactor. Now after this Marshall compaction, so as per the SHR, they developed super wave gravity compaction. Here, the compaction is by leading action. So we will see this also how this compaction works. So leading action means what? So it is basically it will shear the mix, right, by compaction, like the way it happens in the actual roller compactor. So now this roller compactor is an equipment where we can simulate the field conditions in the laboratory. Let's say you want to place a mix at 7% air watts, right? So here we can compact in a similar way in the roller compactor, and then take the course. Basically, we prepare some slabs of bituminous mix, right? And you can take the course and you can test those cores. So basically, this method is used to obtain like a field compacted specimens or field compacted sample in the laboratory. This way, we can go the results can be more near to the field observations. Steel wheel roller, what you see in actual roller compactor in the field, site on the field. This is like a steel wheel roller, right, where this will compact the mix inside the slab. The compacted mix can be used in the wheel tracking device to remember red testing with different air voids, different mix properties. Second and third thing, the whatever prepared sample. This sample can be lateral core. You can take a core, right, cylindrical core, and further test for other properties, let's say modulus, dynamic modulus, or any other property as desired. So the compaction what applies is similar to the field compaction, because it moves like a roller to and fro, where it applies kneading action, right? Unlike the impact device of Marshall, it applies kneading action where the aggregate arrangement or aggregate configuration is similar to what is in the field. If you see this Marshall hammer, the aggregate or compact impact. So what happens there? The aggregate has only 1D motion. It just goes down as a compact. It won't get rearranged. But here, the aggregate gets rearranged as it undergoes kneading, depending on the mix stiffness or the type of bitumen being used, the grading being used. So this will simulate the field compaction in a more better way than the Marshall compaction studies. So we'll see how it is operating. So you can see it is basically initially it is initializing the position. So it's a hydraulic machine. That means it works on the hydraulic concept where you use the hydraulic oil to apply the load, pressure or other to control the force and all. It is slowly moving down now. The roller what we use, the roller portion will perfectly fit into the mold. So there are different kinds of mold. In this we are using D2 mold and roller size is D. And you can see a rod right in front of the mold. That rod is as a safety precaution where the mold should not get displaced while the plate moves to and fro. Now this plate moves to and fro, you can see. So it's moving to and fro. And it's applying a load and it gets compacted. And this compaction is almost similarly the way we see in the field where the steel wheel rollers will compact the mix by kneading action. Let me show the control panel also how it is. So you can see how this control panel is. You can see the load, right? It's around 11.10 kilonewton, right? And then the current height of sample. So you can, if you want to vary the height, in other words, if you want to fix a particular air voids, you can control the height so that you will get that particular air voids in the mix. So it's now 12,000 newtons, that is 1.2 tons what is being applied in this particular thing, right? So this is a control panel for this roller compactor. So here you can compact the mixes for different types of properties. It can be density of mix, it can be height of the mix, it can be air voids of the mix. So this way you can control the mix properties, so to whichever the desired property you want. Later on you can take a core or test in the wheel tracking device. Now this is the wheel tracking device. So you can see here the different parts of the tracking device. Now this is the control panel, right? The emergency button is power off or off, reset button, and this panel is used to set temperature. Now currently we have set for 16 degrees and now it is 31.6 degrees, right? And then there are different function keys where we can use to operate this particular wheel tracking device. So now if you see here, actually if you open that door, it will stop. You can see here how the table is moving to and fro, right? The table moves to and fro, right? This particular cantilever beam has a load here, right? Now the load on the sample is around 70 kg or 700 Newton, right? So that load is applied on the particular bituminous mix. Now this bituminous mix can be compacted in the roller compactor, which we will show, to required density and required air voids. So if you open the door, the test will stop, right? So you can see here basically it's a thermally controlled chamber. It means you can set temperature whatever you want, like 60 degrees, 50 degrees, what is the expected temperature in your field, right? Wherever you want to test the bituminous mix, the temperature can be set in this particular chamber, right? It has heating coils and some fans distribute the hot air. So now this particular cantilever beam, right? The loading is here basically at this point. At this point, the load is around 70 kg or 700 kilonewton, 700 newtons, and then there is a LVDT. Now this LVDT or linear variable displacement transducer will determine how much depth, right, or how much retting is being undergoing at every cycle, right? One cycle means 1 to 1 flow. That means one like this and come back. So 1 to 1 flow is called one cycle, right? So now as the wheel loads continuously at high temperature at 60 degrees, after several passes, the LVDT will, the value of retting will increase gradually, right? Now that measurement is made by the LVDT, right? Linear variable displacement transducer, right? If you see this particular wheel, the rubber also, the hardness of rubber also matters. Matters what kind of rubber you're using. It's using a steel wheel, the results will be different. If you're using a studded wheel, the results will be different. If you're using a particular rubber of given hardness, the results will be different. Normally, whenever you do any rub testing or the wheel tracker test, you need to specify what was the hardness of the rubber, right? It can be 80 or 90 or 70. So you need to specify the rubber hardness whenever you use the wheel tracking device, because the results depends on the rubber hardness also, right? So and then this particular mix, right? Now if you run this particular mix, it will slowly start showing the retting, but not immediately. It may take around 1000 cycles or further much more or many cycles, right? Normally this test is conducted up to 20,000 cycles, right? They will measure the red depth continuously for 20,000 cycles, and then they will plot a graph between the retting depth or deformation first number of cycles. So initially there will be a sudden increase and the red depth because of secondary compaction, and then there will be slower rate increase in the red depth. After the mix goes towards the failure stage, there will be a sudden change in the retting, right? A sudden increase in retting. This way, this particular mix can be used, this device can be used to determine the retting ability or retting susceptibility of a mix. Now let's say if you are comparing two binders, one is VG30 and VG40. Okay, now we can develop two mixes of same relation and test in this particular device and see how the retting behavior will vary as a function of different binders. Similarly, if you have different gradation, let's say a dense bituminous macadam or a stone matrix asphalt, then you can prepare slabs in this particular mold and then test how the gradation effect can be on the retting susceptibility. This way, this particular device can be used to see the retting susceptibility of the mix. So further, let's say now if you want to compare this with the field retting, so there are many studies where they try to correlate, right? If this is 2 mm, right, for this particular cycles, what would be the expected retting in the field for a given traffic level? So there are many studies where they have performed this kind of correlations as a part of developing a guidelines. So this way, this equipment can be used to study the retting behavior or to correlate the field performance with the lab performance, right? So let me keep this machine running. So this machine actually, as a point of safety, it will stop automatically when you open the door. So now you can see here is the number of cycles. One cycle means 1 to 1 flow motion, and this is the red depth. Now currently it's a new sample, so this red depth has been still recorded. This temperature, right? So temperature what we have currently in the chamber now, but we have set for 60 degrees, right? And then this, 60 degrees here. So this way, this control panel will give you data what has been these samples undergoing. Secondly, the same data can also be retrieved in a computer. So this software, this equipment can also be operated with a computer. So where you will get the every cycle data in this particular software.